Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 13, changing the base. Okay, time to change the base. Exercise 1, assume that x, a, and b are all positive real numbers, so that a is not equal to 1 and b is not equal to 1. So we don't want to use 1 for a and b. All righty. It says, what is the log base b of x in terms of log base a of x? The resulting equation allows us to change the base of a logarithm from a to b. Okay, so the first thing we want to do is we're going to let L equal log base b of x. Okay, that's the first thing we're going to do. So it's saying, what is the log base b of x in terms of log base a of x? So we're changing the base. Okay, so if we let L equal log base b of x, then we take our rule and we take our base. Since this is true, then we can now say b to the power of L equals x. Okay, by that last lesson we did. Okay, that's lesson 12, I believe. Okay, so log base b of L equals x. So if we take the logarithm of base a of both sides now, then we're going to get log base a of b to the power of L equals log base a of x. Okay. Now we're going to start using the rules that we learned in the last lesson or two, and the L will go out in front. So now I'm going to move this up here. So this power becomes the leading coefficient. So it's L times the log base a of b equals the log base a of x. Now, if we are trying to solve for L, then we're going to divide both sides by log base a of b. Okay. And when I do that, the log base a of b cancels over here, and we're left with L equals log base a of x divided by log base a of b. And if log base b of x is L, now we're going to finish and now substitute in for L, and log base b of x equals log base a of x divided by log base b of a. Okay, so this is the change of base formula right here. All righty, and once we put some numbers into that, it actually is really easy, and we'll get to that in a moment. So now number 2. It says approximate each of the following logarithms to 4 decimal places. Use the log key on your calculator rather than logarithm tables. First, changing the base of the logarithm to 10 if necessary. Okay, so the first thing I would do is just simplify this and say, well, the log of 3 squared is going to be the log of 9. Okay, and I'm going to get my calculator out and just do log 9, enter. And it's approximately, and where did it say to round? 4 decimal places. Okay. 9542, the 4 goes away. 9542, 0.9542. Okay. Okay, we also could have brought the 2 out in front and said 2 log 3, but anyway, and I guess I could show that. So if we did that, then it'd be 2 log 3, and we'll get the same answer. All right, B, log base 3 of 3 squared. All right, so I can't put this in my calculator. There's a log button, which is base 10, and there's the natural log button, ln, which we haven't gotten to yet. That has to do with being a base of e. But before we get there, we have a log base 3. Well, we just learned the change of base formula up here. Let's go back to that. And what does it say? Log base b of x equals, and our b in this case is 3. And our a is going to be, first of all, I want to take this 2 and bring it out in front. So that's going to be 2 log 3. Okay, let me think about this a second. I'm trying to explain this. So log base b of x. So I'm over here, I'm just going to write b equals 3. That's right here. A equals x equals. Okay, so if we have the base of 3, that's our b. B occurs there, b occurs there. So if I set this up as a fraction, we're going to get log base 3 down here because this is our b of some number. Okay. Actually, not log base 3. So what is a? Log base b of x equals log base a. Well, our base a, we're trying to get it to be base 10. And our x is going to be the number that's in the parentheses, which is 3 as well. This power goes out in front. So we're going to end up with 2 log base 10, but we don't need a 10 there because log base 10 is just simply log. So that's going to end up being 2 log x, which is 3. So it's going to be 2 log 3 divided by the log of base b of a. And that's just going to be log base b of 10. And our b is 3. Log base 3 of 10 is just simply log of 3. Okay. And so this is what we're going to put in our calculator. Or we don't even need a calculator here now. So it's going to be 2 log base 3. And this is going to get simplified in a moment. So if you don't understand this, I will explain it in different words. Log of 3 divided by log of 3 is 1. 2 times 1 is simply 2. So if we have a base and we have this number the same, they just cancel and you're taking the log of the power. Okay. In this one, we're going to get our 2 out in front. 2 log 3 divided by the log of our base, which is 2. Okay. So this is going to be 2 log 3 divided by log 2. I need to put that in the calculator. Nothing cancels. So I'm going to put the numerator in first, 2 log 3. That way I don't have to deal with parentheses. So there's my numerator. Now if I just hit divide, it's taking that divided by, and I'm going to take the log of 2 and hit enter. And I get 3.1699, and then that 2 rounds down, 3.1699. Okay, so there is page 1. I will explain it a different way on the next page. Okay, page 2, number 3 says, in lesson 12, we justified a number of properties of base 10 logarithms. Working in pairs, justify the following properties of base b logarithms. So we have log base b of 1 equals 0. So if we let L equal log base b of x, Okay. That means b to the power of L equals x by our rule. The base to the power of what it equals is equal to what we're taking to the base of b. So if that's the case, then in our situation here, x is 0 and x is 1 and L is 0. L equals log base b of x, then when x equals 1 comma L equals 0. So if L is 0, no matter what the base b is, as long as it's not 0, then we get 1. Okay, we never take the base of 0. Okay, so part B, again, we're going to let L equal log base b of x, and that's going to mean that b to the power of 1 equals b. Well, I'm substituting it in first, so I'm skipping a step there. That's why I paused. I apologize. So we're writing this log base b of L therefore equals x. So then when x equals b, L equals 1. In other words, whatever the base is, if this equals the same thing, then it's got to be the power of 1. Okay, got it. All right. Next, let L equal log base b of x. So therefore we get b to the L equals x. Then when WHEN. So when we look at this, what do we have? We have R. What is X? L is my R. Okay. And X is B to the R. So then when X equals B to the power of R, comma, L equals R. All right. So what is that saying? When we have a base and this number is the same, if we're taking 5 to the base 5, the power of 5 is going to be our answer, in other words. So when x equals b to the r, L has to equal r. So b to the r is r. All right, so part D. Then these get a little bit more complex. All right, so part D. This one here is a power. So if we let L equal log base b of x, then b to the L equals x. So therefore, then when x equals, and what is our x in this situation? Log base b of x is equal to b to the L equals x. So when x equals x will equal b log of b. It will equal b to the power of log base b of that x. Okay. So let's think about this. Log base b of x goes to b to the L equals x. Then when x equals this, I guess I don't need this when. In this case, x is just simply that power, or the other side, which is what we started with. So b to the power of log base b of x is just simply x. So when we're taking the log and the base is the same as this base, they cancel and we just simply get x, okay? And now e, we have log base b of x times y equals log base b of x plus log base b of y. That's just one of our rules. So this is what, e? So by the rule, and then they're going to use all kinds of weird letters here. So let me see. We're going back to lesson 12 again here. So by the rule, a, base a, to some number q plus r, it's a q by the way, a to the q plus r is going to equal, well, let me see, by rule a to the q times, I forgot what to write here. It is going to be a to some number q times r is going to equal a to the q plus r. It's still not right. This has to be a to the q times a to the r. Okay, so what we're doing is we're distributing. So this would be log base b of x times log base b of y. So when a to the q times a to the r equals a to the a plus r, then we have b to the log base b of x. That's right here. Times b to the log base b of y. And that is going to equal b log base, or b to the power of log base b of x plus log base b of y. Okay, so if you have two bases being multiplied, then you just add their powers. That's all that is. Okay, so then we take property 4 from the prior lesson, and then we get b log base b of x. That's this right here, times b log base b of y. Well, that's just going to simply, the b log base b's in the b, there should be a b here. Actually, no, I'm skipping a step. So I do need to use this though. So we're going to continue. Let me change colors now. So now this is going to become, and I'm going to distribute and split this up, b to the power of log base b of x. Let's see. This is property 4, b log base b of x times b log base b of y. Equals x plus y, or times y, x times y. So in this case, then we get x times y is going to equal b log base b of x plus b log base b of y, which is right here. So by property 4, again, x times y is going to equal b to the power of log base b of x times y. We just combine. So the exponents must be equal, and the log base b of xy equals log base b of x plus log base b of y. So therefore, if we have the log base, let me see. So log base b of x times y. So now I can say over here, this one's a little tricky. Log base b of x times y is going to equal the log base b of x plus log base b of y. Okay, that might be a little confusing, but anyhow, that's that. Okay, continuing on with these, f, log base b of x to the r equals r times log base b to the x. That's just the power rule. So by the rule, what we're going to have is if we have some number a to the power of q to the power of r, then that is going to equal a, and it's a power rule, q times r. So what we have here is if we have b to the power of r times the log of b to the x, log base b of x, then that is going to equal, so what do we have here? Our base is b, we have an r, and we have a log base b of x. This r here would be our q, and this log base b of x would be the r. All right, so that's going to equal b, our base, to the log base b of x to the power of r. Let me erase that. That's an x. Okay, so by property 4, b log base b of x to the r, this here then would have to equal x to the r. Because anything b to the power of log base b would cancel, and we're left with x to the r. Okay, so x to the r therefore is going to equal, x to the r is going to equal b to the r log base b of x. Okay, so if this is equal to this and this is equal to this, by the transitive property, x to the r equals b to the r times log base b of x. So by property 4 again, x to the r equals b log base b of x to the r. B to the power of b to the power of log base b of x to the r. And here, let me put that all in the same parentheses. X to the r parentheses. Okay, so x to the r, b log base b of x to the r. So this is just that power rule and moving the r inside. So the exponent must be equal and log base b of x to the r equals r times log base b of x. Okay. Moving on to G. By property 6 this time from the prior lesson, log base b of some number x to the k. So if we have a log base b of some number x to the power of k, that equals k times log base b of x. So if we let k equal -1, this is where it got flipped. Did that in one example in the last lesson. So now we're going to let k equal -1. All right, so when we do that, so for x not equals, so then for some x, and it can't be 0, the log base b of x to the -1 equals -1 times the log base b of x. Okay, just taking that power, bringing it out in front. So therefore, we can then say log base b of 1 over x equals the negative of the log base b of x. Okay, that's pretty straightforward. All right, h. This is property 5. Log base b of x divided by y equals log base b of x minus log base b of y. So when we're dividing, we subtract. Same with these rules are the same as the exponent rules you did at the beginning of grade 8. Okay, so these are just the same as the exponent rules. When multiplying, we add, and when dividing, we subtract. All right, so h. So by property 5, log base b of x times y. So we start off with the log base b of x times y. That is going to equal log base b of x plus log base b of y. Okay, and then once I do that by property 7, again, y cannot equal 0. So I'm going to say that for any y that does not equal 0, comma, log base b of y to the -1 is going to equal -1 times log base b of y. And therefore, log base b of 1 over x equals log base b, not 1 over x, xy. Okay, so if we have log base b of x divided by y, then that is just going to become log base b of x minus log base b of y. Okay, so now number 4 just says to use the ln, natural log, and the log key on your calculator to find the value of each logarithm to 4 decimal places. So this is just simply getting familiar with your calculator. So you turn it on, clear it, and I want the natural log of 1, and that's ln 1. And when you're just doing a calculation, you can close that parentheses, but if you don't, it doesn't affect anything. Okay, either way, you're going to get the same answer. So that's 0. And let me fix this so my calculator doesn't disappear. Okay, so now I'm going to do the natural log of 3 and hit enter. And that is approximately 1.0986. Natural log of 10, 2.3026. Natural log 25, 3.2189. Natural log of 100 is approximately 4.6052. And now we're going to go over to the logs. So the log of 1 is 0. The log of 3 is an approximation 0.47712. Log 10 is 1. Log 25 is going to be 1.3979. And the log of 100 is going to be 2. Okay, so there's just some practice. Oh, and by the way, if I round to 4 decimal places, I should do that to all of them. 0.0000, 0.0000, 1.0000. Number 5 says, make a conjecture that compares values of log x to natural log of x for x greater than 1. So when x equaled 1, they were both 0. But then when x was greater than 1, we got 1.09, we got 0.47, 2.31, 3.2, 1.3, 4.6, 2. So it appears that for x greater than or equal to 1, comma, log of x is less than the natural log of x. So we would say the log of x is less than or equal to the natural log of x. All righty. All right, next page, number 6 says to justify your conjecture in exercise 5 using the change of base formula. So I just brought this in, it's just easier than writing. So by the change of base formula, the log of x equals the natural log of x divided by the natural log of 10. So you take when we just have log of x, you can take the natural log of the big divided by the natural log of the base or the little, and that when it's not, there's nothing there, that's called a common log, that is 10. So the ln of x divided by ln of 10. So therefore, then we can say the natural log of 10 times the log of x, multiplying both sides by a natural log of 10, equals the natural log of x. And for example, the natural log of 10 is approximately 2.3. Okay, I think we did that on our calculators. Or did we? ln of 10 is approximately 2.3. Log of x is less than or equal to the natural log of 10 times the log of x. And thus, the log of x has to be less than or equal to the natural log of x. So now it says write a single logarithm. Now we're going to have combinations. We have sums, we have differences, and they want us to write a single logarithm. Okay, so what we're going to do here is the natural log of 4 is going to stay the same. So it's going to be ln of 4. Okay, but this minus here, if I get rid of that minus and make it a plus, we're taking the reciprocal of 1/3, which is 3. So it's going to be plus the natural log of 3. And this 3 is going to be the power, which is 3 cubed. And then it's going to be plus the natural log of 2. Okay. So then I can say that is equal to the natural log of, and then we have 4, we have 3 to the 3rd power, and we have 2, and those all get multiplied because this is addition. So it's going to be 4 times 3 cubed times 2. And then we simplify that, and the natural log of 3 to the 3rd power is 27. 27 times 2 is 54. 54 times 4 is 216. So I get the natural log of 216. Okay, and if I simplify that, then 6 times 6 times 6 is 216. So then I can rewrite that as the natural log of 6 to the third power. And then the 3 will go out in front. And we end up with 3 ln 6. Okay, 3 times the natural log of 6. Any of the last three expressions would be acceptable because it is 1. Natural log of 216 is fine, but we can simplify it to natural log of 6 cubed, and that does get simplified to 3 times the natural log of 6. So we're going to do the same here. So this is going to be ln of 5. Nothing changes. That's pretty simple. And then we get this 3/5 natural log of 32. So this is going to become, this is the power rule. It's going to become 32 is our base and 3/5 is the exponent for 32. And then it's going to be plus the natural log of 1/4. Okay, the minus sign will turn into, actually, do I even want to do that? Let's not do that. Undo. Let's just leave it minus the natural log of 4. That's going to come out to be division when we're finished. All right, so the natural log of 5. So this is going to equal, how do I, let's not put it underneath. Let's just say equals the natural log of 5 plus, and think of 32 to the power of 3/5 as the 5th root of 32 cubed. Okay, that's what it means. So what times itself 5 times is 32? Well, that's going to equal 2 cubed. 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Okay, so 2, the 5th root of 32 is 2. 2 cubed is 8. All right, so that's going to simplify now down to natural log of 5 plus the natural log of 8 minus the natural log of 4. So there I can combine these by multiplication. That's going to be the natural log of 5 times 8. And we're going to divide by, because minus means to divide, the natural log of 4. Okay. And that will simplify out to be the natural log of 40 divided by 4, which equals the natural log of 10. All right, so the natural log of 5 plus 3/5 the natural log of 32 minus the natural log of 4 is simply the natural log of 10. You can plug that in your calculator, get an answer, and check. Okay. What is the natural log of 10? We just did it, 2.30258. So if I plug it all this in my calculator, you should get 2.3025 or 6 rounding. All right, number 8. It says to write each expression as a sum or difference of constants and logarithms of simpler terms. Okay. So this is going to equal, and we're going to split this all up. So multiplication. So I can rewrite the square root of 5x cubed. That's going to equal the square root of 5 times the square root of x to the third power. We can split those up. And in doing so, I can then say it's addition. So if I have the natural log of this and I split it up like this, it's going to become the natural log of the square root of 5 plus the natural log of the square root of x cubed. Okay, that's, I just did like 2 steps in one there. And then it's minus, because it's down in the denominator, the natural log of e squared. Okay. So the natural log of 5 is the same as saying 5 to the 1/2. So that can simplify as taking the power out in front, 1/2 the natural log of 5 plus 3/2. Okay, remember this is a 2 here. X to the 3/2. 3/2 can go out in front. 3/2 the natural log of x. I suppose I should have these in parentheses. So 1/2 natural log 5 plus 3/2 natural log x minus 2 natural log e. We have a rule I just thought of. Let me show you. 2 natural log e is 2. Natural log of e squared is 2. Okay, so if you take the natural log of base e, they cancel and the power is just your simplified answer. So how about I just simplify it in one step rather than doing the power rule first, and then, so that's just going to become 2. Natural log base e of some power is going to equal just that power. All righty. So now that we have 1/2 natural log 5 plus 3/2 natural log x minus 2, that's as far as we can go. I cannot simplify this any further. It says to write each expression as a sum or difference of constants and logarithms of simpler terms. And that's that. All right, so part B. So now we have the natural log of x here. Let me extend the page so I'm not way down here, and let me get rid of this. So let me pause the video. Okay, so here we go. The natural log of the quantity x plus y quantity squared divided by x squared plus y squared is going to equal the natural log of our numerator minus, the division means minus, the natural log of our denominator. Okay. And then once we do that, we want to simplify this by the power rule. The 2 will come out in front. So this is going to equal 2 times the natural log of x plus y minus the natural log of x squared plus y squared. Okay. The point of this simplification is that neither of these terms can be simplified any further. 2 natural log x plus y minus natural log of x squared plus y squared is in simplest form, and that's it. Okay, page 5 brings us to the end of lesson 13. Review the lesson summary, all of these rules, and go to your problem set.